Now that we're going to build this graph dynamically, let's remove all this hard-coded SVG. In our app.js, we get rid of the code that we did in the previous episode and uncomment the call to get the data from the tag tree website. We set the width of the SVG and the height of the bars. We have to let our bars represent the relative sizes of views for each screencast, so we need to map the data sizes to sizes that would work with our screen real estate. This is where D3 really shines. It's got a bunch of functions we can call to do this mapping for us. We get the maximum size from our data by calling D3's max function and passing in the data with a callback that returns the value we want to calculate the max on. In our case, the view count. Remember, we've set up our environment to enable ES6 in an earlier episode, so go check it out if you haven't yet. Now that we've calculated the max value in our data, we can go ahead and build a function with D3 that we can use to translate our domain values, meaning the view count values on our screencasts, to a value in pixels that we can use to plot it to our graph. Luckily, D3 makes this super easy with its scale functions. Let's call our function xScale. We use the D3 scale module and specify that we want to build a linear scale. This function expects an array that represents the min and max values of our domain. In our case, we specify 0 as the min and the max value we calculated earlier as the max. After specifying the min and max for the domain, we need to specify the min and max for the graph dimensions, in our case 0, and the width of the graph itself. To test that this scale function works, let's log out the result of passing 500 into our function. As you can see here, with the max width of the graph being 600, a domain value of 500 gets translated to 110 pixels. And 1000 to double that at 220 pixels. Let's log out the result of calling the scale function on each item in our screencast array. We loop over the screencast array with a simple for loop, and log out the result of calling the xScale function with the current screencast view count value. As you can see, this function gives us useful pixel values that we can use on our screen to represent our data. This is pretty neat.